What you're looking for with a university is a consistent heat load, so that the CHP is providing the heat from the CHP unit into the heating network. Typically a university will actually have its own heating network system that we connect into, normally within the energy centre. And then as part of that, clearly we're offsetting primary energy requirements from utilising the national grid as well as the boiler. So those are the two real main benefits, as well as of course you can also operate the CHP as a standby generator in certain conditions if the design and the technical requirements are actually available. The other thing with the CHP unit with a university, and we've done this on various universities as well, is to actually operate the CHP with an absorption chiller. And that's a way of utilising the heat in the summertime, when clearly the heat loads are much less when compared to the winter demands, because you need heating in the winter, whereas there's a lot less heating requirement on a university campus. So what's quite really good about the product range is we can actually find the product to meet the actual potential sector. So with a university sector, we've got machines that are as large as 2 megawatts, but also we've got machines as small as 100 kilowatts. So the variance is really dependent on the profiling of the site in terms of its energy usage, typically base load requirements on heat and clearly the power requirements of the facility as well. We try to have what I would call a cradle to grave approach with a scheme. So what we would look to do is the feasibility study actually may have been already completed by a mechanical electrical consultant. However, Kajenko has the experience clearly of 30 years to be able to do the feasibility studies and actually do a lot of that design work as part of our service. Once the CHP feasibility is carried out, we have sized the CHP, or we know what the CHP size is. We would then go through the sales process to ensure that commercially that everything was as it should be in terms of the capex and also of course the operational aspect, which is really important for a CHP unit to be successful.
Initially, once we've agreed what we're going to do with the client through a detailed design phase, we'll have a pre-start meeting where everyone is going to be involved in the project is going to sit down around a meeting and talk through the various health and safety aspects involved in the installation, and also what potential conflicts we could have on site in terms of kind of noise creation or other works going on at the site during our installation phase. From that point then we'll have a mobilisation phase where we basically get set up on site, create our compound area, and basically get started, get the contractors working and following the programme that we've agreed with the client.
When we looked at the university's actual requirements, we were looking to provide a 1.4 megawatt machine into the facility, connected to the district heating network, and the benefits that actually at that time were predicted were around about £400,000, and that was based in 2011 on what we call the differences between electricity and gas, otherwise known as spark gap. The CO2 emissions benefit was typically, again, estimated to be 15% when compared to conventional means. So here I am at the University of Bradford. This CHP unit here has been installed since 2011. It's a 1.4 megawatt unit producing both power and heat for the university campus. I'm actually standing on top of the exhaust gas heat exchanger, so we're recovering heat from both the engine jacket and the oil circuit from the machine, as well as the exhaust. And all that heat is utilised within the university itself. What we also do, we actually run the machine when the campus needs heat, but in addition the design also incorporates a thermal storage vessel, so that when the university campus is actually up to its heat requirements, we store an allowance of heat that allows us then to use that heat when the machine may be off for servicing, or when actually the heat isn't needed at that time, but then is utilised later in the day. Typically, we would expect a CHP to last for at least 15 years. The reason why we say that is because we actually have signed up with customers to 15-year maintenance contracts. Maintenance contracts are absolutely key to the success of a CHP. Typically the paybacks are 4 years on average, depending on spark gap. But we do, as I say, sign up to contracts of 15 years plus. And within that 15-year period, we're not only just doing the routine servicing, which would incorporate oil changes, spark plugs and filters, typically what you'd expect on a spark ignition engine, but we're also doing major overhauls. So one of the key requirements of a CHP scheme is to ensure that you've got a long-term operational contracts in place, ideally with the CHP provider who's installed a CHP, so you maximise the potential benefits from the unit over that period. Genco has been in the CHP industry for 30 years, and one of the things that we pride ourselves on is the service backup. Of the employee base, over 50% are related to service support, including the control centre in Horsham, where we monitor our CHP units 24 hours a day, 7 days a week, all year. So the main thing is to ensure that as part of the operational support is that we have a regional structure to the organisation, which creates responsibility for engineers with the area service managers to make sure that they're actually looking after those machines, and creating what's important for the business as well is that the relationship we've created during the sales process, the sales stage through to projects, remains during the whole life cycle of the contract itself.